Welcome to EPG Pathshala. This unit relates to the notions of data, information and knowledge. And as you are all aware, these are fundamental, and understanding of these notions and concepts is fundamental to the science of information and information studies. In this unit, what I propose to do is to give you an understanding of the notions of data, information and knowledge, and also emphasize the differences between knowledge, data and information from a library and information science perspective, from an LIS viewpoint. In normal usage, it is not uncommon for people to use the terms data, information and knowledge interchangeably, but for us these have different connotations, and it is better that we understand clearly what the connotations are. It is not out of place here to begin with the quote from T.S. Eliot, who posed the question, where is the wisdom we have lost in knowledge? Where is the knowledge we have lost in information? In today's world of big data and abundant data, it is just as meaningful to ask, where is the information we have lost in data? There are various definitions, and these definitions do not even match. We take in our discussions, therefore, a particular perspective and a particular viewpoint which is of value to library and information science professionals. First, let us try to begin by understanding the relationship between these three terms before we actually look into the connotations, what data connotes, what information connotes, what knowledge connotes, and above this the term wisdom is used. But before we go into the definitions of these terms, let us try and understand the relationship between these terms. This is best illustrated by what is referred to as the knowledge hierarchy, which you see in the diagram here. The figure suggests a certain degree of dependence of one on another. That is to say that data is a prerequisite for information, and information is a prerequisite for knowledge, and of course knowledge is a prerequisite for wisdom. While this is generally true, it is not necessary that it is always valid. However, it is not necessary for us at this stage to go into the details of this. We in the library and information science profession can assume that there is a certain amount of dependence of information on data and knowledge on information, and proceed further. Let us first come to the notion of data and look at some definitions of this particular term. Data is defined as being discrete, objective facts or observations, and by its very nature, data is raw facts and figures that we derive from the environment. And these data or facts may relate to an event, an entity, or to some other kind of transaction. So, the most important thing that characterizes data is that it is not organized until it is processed, and it lacks a context and therefore cannot be interpreted. Data is also seen as facts, and in computer sciences and system sciences, data is also seen as symbols, signal, or stimuli. Facts and figures which relay something specific but which are not organized in any way, which provide no further information without the context, can be considered as data. These, as you are aware, do not have much impact on any typical manager. Let us look at a couple of examples. A piece of data, for example, such as 23.01.48 may not be very meaningful because there is no context. It becomes meaningful once the context is provided. That is, suppose I say that 23.01.48 is the date of birth of X, well, it makes sense to all of you. Similarly, a string of 13 numbers may not make much sense until the context is provided, and I tell you that it is the international standard book number of a particular book. That is, only when the context is provided is it possible to infer information from data. From a computer systems point of view, data could also simply mean bits and bytes amenable for storage and transmission using a digital medium. I have already said that data is unorganized and unprocessed facts. I have said that data represents unorganized facts and unprocessed facts. When we actually look into the nature of data, we will find that in most cases data is static in nature. It usually represents a set of discrete facts about a thing or an event. What we can actually say is that data is a prerequisite for information. An individual or organization sometimes has to decide on the nature and volume of data that is required for creating the necessary information. We will be looking at a few examples on this subsequently. The term data is also used to refer to a set of values which are quantitative or qualitative variables. For example, I can have a matrix of districts on a column, and then the literate population, the gender-wise distribution of population, etc., in different columns. So each cell in this particular matrix will give us a piece of information when we actually interpret it along with the context, that is, in the context of the rows and the column at which that particular cell occurs, the intersection of the rows and column. When we think of data, generally what comes to our mind is that data is generally presented in the form of tables, tabular forms. But data is also represented as graphs. Data could also be represented in the form of a hierarchy. Graphs tend to present data in a visual form which makes it easy for people to understand. In that sense, it gives us information which is easily interpretable, understandable. We will now look into some of the ways by which data is actually captured. In reality, in practice, data is captured by a variety of means. Broadly, these can be classified into direct methods and indirect methods. For example, when a computer or a barcode reader reads a barcode and enters the data, it is a direct method of capturing data. Instead, if we give the data to someone and ask that person to key in the data, it is an indirect method of data capturing. Indirect method of data capturing is always subject to human errors. We will now look at some of the tools that are used in practice to gather data. Data is gathered by means of direct observation. We know that we can observe, for example, go to a library, observe how many readers are sitting in the reading room, how many readers are using reference service, etc. And by means of this direct observation, we can gather data. We also use in practice several survey instruments to gather data. You may interview somebody or a set of people. You may circulate a questionnaire to a number of people and then gather data that you require for your purpose. In science and engineering, usually data is generated through laboratory experiments. There are also certain sciences where data that is generated is largely by means of field surveys, for example, geography and geology. But one thing that is common to all methods of data gathering and data collection is that when we collect data, there is always a purpose behind that. The purpose is going to determine the volume and nature of data that we actually collect. I made a reference some time back to field data. So, we can consider field data as one kind of data. This is generally used to refer to raw data collected in an uncontrolled environment. Geological surveys, field surveys that we do, many of the surveys that libraries undertake collect data from the field. This can be considered as field data. Experimental data refers to data resulting from scientific experiments. I suppose we now have a fairly good idea of what data is all about. We will next come to certain other attributes of data which are generally used to suggest its quality. Three factors are generally associated with the quality of data. One, how accurate the data that you have collected is, the accuracy of the data. We know, for example, that when we use a questionnaire to collect data, we may not always get very accurate data. The second factor that determines the quality of data is how up to date the data is, that is the up to dateness of the data. If we have data that is very old, that is not current, the information that we are going to derive from that data is also going to be invalid. So, up to dateness of the data is another very important aspect that affects the quality of data. The third quality aspect is completeness of the data. All these, how comprehensive it is, how complete the information that you have is. All these affect the quality of the information that we are going to actually derive from the data. Having said all this about data per se, we will next look at the notion of information. Information can be defined as organized or structured data. Data that has been processed in such a way that the information that we now have has relevance for a specific purpose or context and is therefore usable, meaningful, valuable and relevant for the purpose that we have in mind. However, this definition contrasts with the suggestions that the difference between data and information is structural and not functional, because here we are looking primarily at the difference between data and information in terms of their function. Information is inferred from data. It is processed data. It is data that is endowed with meaning and purpose, and could also be seen as an aggregation of data. It's good to have a better understanding of the difference between data and information, although in practice, in common usage, many times we use the term data and information more or less as equivalent terms. In reality, there are differences between the two. To illustrate this point, let us say the noise that I hear is data. Some kind of noise that you hear is data. If, for example, you infer based on the noise that you hear that it is the sound of a telephone ringing or the sound of a car engine running, or it is the sound that comes out of a bullet fired from a revolver, then it is information. So, we understand, just the noise per se is data, but based on our understanding the context, whatever it is, if we infer that this is the object that made this particular kind of noise, or what actually this particular sound is about, where it is coming from, then it is information. In this sense, information could also be seen as a subset of data involving manipulation of raw data to derive some meaning. That is, information is, it includes data that possess context, relevance and purpose. According to the management guru Ackoff, information is found in answers to questions that begin with who, what, where, when and how many. So, an answer to any one of these questions could be considered as information, because that provides the context for the data that we are actually dealing with. To facilitate processing of data, especially large volumes, often information is encoded as data. Again, you can understand this with the help of a small illustration. It is not very uncommon for us, when we administer a questionnaire, to encode certain answers. For example, you may encode gender as M and F, standing for male and female. It may also be found that in many questionnaires which seek an opinion of the user, you may code the response of the user, giving him certain number of options. For example, you may say, please tick 1 if your answer is poor, 2 if your answer is fair, 3 if your answer is good, 4 if your answer is very good, etc. So, they do not have to write poor, fair, good or very good, etc. in expressing their opinion. They simply have to code it as 1, 2, 3 or 4. This is also something that is very commonly found when we use, when we have to process large volumes of information. Information as a technical term is used in a wide range of contexts. Some of these are relevant for us and there are some units in this particular course which deal with certain aspects of this notion of these notions of information. Mathematical theory of information, for example, uses information in a particular sense. You will understand more about this when you read the unit on theories and models of communication. Systems theory again uses information in a different sense. Library and information sciences, we extensively use the notion of information, the term information, in a different sense. Semiotics, the branch of linguistics, also uses the term information in a particular sense. We are interested in how information is used in library and information sciences. In library and information sciences, information is often seen as documentary records. I would suggest that you people look into the definition of records as given by the Association of Archives, the United States Association of Archives. Later in this particular unit, I am going to give you a diagram which represents the data, information, knowledge, wisdom triangle. We now come to the third component of this particular triangle, hierarchy if you want to call it, the knowledge component. The knowledge component of this DIKW is an elusive concept. It is an elusive concept. No one has really been able to very clearly define what knowledge is. It is really difficult to define. Knowledge is typically defined with reference to information. Definitions of knowledge refer to information as processed, organized, or structured in some way, or else as being put into action. In other words, when we think of knowledge, we are looking at how a particular piece of information is actually put into use in solving a problem. This problem context is especially important in understanding the notion of knowledge. Let us look at some of the ways in which knowledge has been defined or knowledge is understood. Knowledge is human understanding of a subject matter that has been acquired through proper study. Like, for example, when you undergo a particular course, you acquire certain amount of knowledge about that particular domain on which you have completed that particular course. But this is just one way of looking at knowledge. That is knowledge based on learning. Knowledge is also acquired through the process of thinking, through the process of proper understanding of the problem area. What is very, very important for us is to realize that knowledge is not information and information is not data, but knowledge is derived from information in the same way information is derived from data. An understanding of information based on its perceived importance or relevance to a problem area is what actually constitutes knowledge. In other words, it is not enough if we have information, but we should be able to interpret that particular piece of information, apply it in a given problem solving situation so that we are able to solve that particular problem. And for this reason, knowledge is also a cognitive process, the integration of human perceptive processes that help people to draw meaningful conclusions. Let us look at some other ways of defining knowledge. Knowledge is what one knows. During the process of our day-to-day life, we acquire knowledge through a variety of means, and our brain actually builds up a map of what all we know. And as you know, this map keeps changing as we acquire new knowledge, as we get to know something more. And for this reason, knowledge of one person is not the same as knowledge of another person. Knowledge of one person at a given point of time is again not the same as the knowledge of that person at some other point of time. He may have acquired additional knowledge through interaction, through reading, through understanding, through discussion, through a variety of means. A term that is also used in library and information science is the universe of knowledge. Universe of knowledge refers to the totality of all that is known to mankind at any point of time. The totality of, in a way, we can say, for example, that a rough idea of all the knowledge that is known to mankind can be found in all the encyclopedias, general and domain encyclopedias that are available at that particular point of time. To a certain extent, this statement could be considered as valid. But we know that the totality of knowledge known to human beings, that is, the universe of knowledge, changes as humans discover more things, find new things, change their understanding of existing things. We all know how the notion of planet, our knowledge of planet, what a planet is, changed some years ago when they found that some of the planets or some of those are objects which were considered as planets were found not to be planets. So this actually changes the state of knowledge. The signals from our sense organs also keep changing the map of knowledge. One of the most frequently quoted definitions of knowledge captures some of the various ways in which it has been defined by others. It is a fluid mix of experience, it is a mix of values, it's contextual information, it is expert insight and grounded intuition that provides an environment and framework for evaluating and incorporating new experiences and information. Knowledge actually originates in the minds of people who could be called as knowers. In organizations, it often becomes embedded not only in documents and repositories, but also in organizational routines, processes, practices, and norms. Having got a rough idea of what knowledge is, let us now try to understand what kinds of knowledge exist. We can classify knowledge in several different ways. One way of classifying knowledge is on the basis of whether it is procedural, declarative, semantic, or episodic knowledge. Procedural knowledge represents the understanding of how to carry out a specific procedure. That's what a procedural knowledge is. Declarative knowledge, on the other hand, is routine knowledge about which an expert is conscious. It is shallow knowledge that can be readily recalled from our short-term memory. This type of knowledge, what we call as declarative knowledge, resides in our short-term memory. Semantic knowledge, on the other hand, is highly organized. As the name itself suggests, it is chunk knowledge. In other words, we are able to relate different pieces of knowledge to each other. That is, when I acquire a piece of knowledge that is new to me, I am able to relate, or my brain is able to relate that piece of knowledge to something that I already know. So, this requires our ability to recall major concepts, vocabulary, facts, and relationships. Semantic knowledge includes all this. Episodic knowledge represents the knowledge based on episodes, for example, experimental information. There is also one other way of classifying knowledge. We are more interested in looking at this. This classification classifies knowledge into two broad categories: tacit knowledge and explicit knowledge. Tacit knowledge usually gets embedded in human mind through experience. That means I have the knowledge. A surgeon has tacit knowledge about how to perform a surgery. It's not easy for him to transmit this knowledge. Explicit knowledge, on the other hand, is that which is codified, documented. So, all that we find in books, reports, thesis, dissertations, spreadsheet tables, office memos, notes, etc., is all explicit knowledge. Of course, there are people who argue that explicit knowledge is information and all knowledge is tacit. It's something that we need to be aware of, that there is this kind of an opinion also, that there is no such thing like a explicit knowledge. When knowledge is documented, it becomes information. That's how some people look at it. So, tacit knowledge is something that actually resides in the minds of people, and it cannot easily be transmitted or communicated. It is difficult to transmit or communicate tacit knowledge. What we try to do is we try to capture tacit knowledge through a variety of means and convert it into explicit knowledge. Now, this is especially something that is being attempted in the corporate world and what they refer to as knowledge management. In this course, you have one complete unit which will tell you more about knowledge management, what it is, what its processes are, etc. For the time being, we will limit ourselves only to these three notions of data, information, and knowledge. We have looked at definitions of data, we have looked at definitions of information, we have looked at definition of knowledge. Clearly, there are competing definitions and there are different perspectives of data, information, and knowledge in different aspects of computer science and in other disciplines such as psychology, management sciences, and epistemology. What we will try to do here is we will try also to take a holistic view of all these three terms in relation to each other. Of course, we must begin by realizing and understanding that the usage of these three terms has not been consistent and may even be conflicting. For instance, data and information are often interchangeable in computing sciences. Data processing and information processing, they are used interchangeably. Data management and information management are also used to refer to the same thing. What I have tried to do here is to emphasize the difference between data, information and knowledge using Ackoff's definition. Look at this particular table. What you find here, these three categories, data, information, knowledge on the left hand side column and definitions on the right hand side. That will give us an understanding of the differences, the principal differences between how these need to be understood. Data merely refers to symbols. Data processed becomes information, that is processed to be useful for a particular purpose. And as Ackoff said, this should provide answers to these questions: who, what, where and when questions. Knowledge, on the other hand, is application of data and information. It must provide answers to the how questions, know how. I made a reference to this data, information, knowledge, wisdom hierarchy, which is a very popular model for classifying human understanding in the perceptual and cognitive space. The human brain also contains our beliefs and expectations. It is able to link knowledge units and reason. For example, I am also able to say what or see what happens if I do something like this. That the brain has the ability to reason, and therefore it is said by many that only the brain can store knowledge, and computers are not artificial brains. They just process data or information. That is because they do not understand what they are processing, whereas the human brain does understand what it is processing. Some people have suggested, for example Zins, that knowledge being so subjective, so abstract, is not the subject of study in information science and is often defined in propositional terms, while Zeleny has asserted that to capture knowledge in symbolic form is to make it into information. Again, we come back in this particular definition to what we asserted some time back, that all knowledge is tacit, and when it is captured and documented, it does become information. In the last few slides, what I am going to do is to merely summarize the discussions that we have had so far. Evidently, the three terms are interpreted in several different ways, and there is no one definition for each of these terms that is universally accepted. The definitions are also a function of the disciplinary perspective from which these are being looked. Library and information science people will look at information from a different perspective. Computer science people will look at these three terms from a totally different perspective, and so are cognitive scientists, knowledge management specialists, etc. Alan Frost has attempted an abstraction of the definitions which capture the essence of all these three terms. Please look into this particular source document which is available on the internet. What you are looking at here is the knowledge hierarchy. This particular triangle where we have at the bottom occupying a vast area is data, which represents facts and figures which relay something specific but which are not organized in any way. Once this data is contextualized, categorized, calculated and condensed, it becomes information. It is at a higher level and is derived from data. At an even higher level, we see knowledge. Knowledge is know-how, understanding, experience, insight, intuition and contextualized information. This has been very clearly explained by Davenport and Prusik, who suggest that for data to become information, it must be contextualized, it must be categorized and calculated and also condensed. Information thus paints a bigger picture. It is data with relevance and purpose. It may convey a trend in the environment or perhaps indicate a pattern of sales for a given period of time. I would also like here to give you another example. For example, a library may have data about book vendors, price of each item of book that it acquires, the date of placing a book order, the date on which the book is actually received, etc. as a part of its database. These bits of data could be processed to derive a variety of information. For example, from this data, I can find out the average time lag between placing an order for a book and actual supply of that particular book, the actual day on which that particular book arrives. I can also find out the vendor who is very prompt and the vendor who requires several reminders to supply books after placement of order. I can also infer from this data, draw information about the volume of business in terms of money, how much of business is going to which vendor and to another vendor. Essentially, information is found in answers to these questions. Like I said before, who, what, where, when and how. These are some of the questions that we can ask, for example, with regard to the data that a library maintains in the form of its accession register, let us say in a digital form. Knowledge is closely linked to doing and implies know-how and understanding. The knowledge possessed by each individual is a product of his experience and encompasses the norms by which he evaluates new inputs from his surroundings. We shall conclude this with the statement that knowledge is a mix of framed experience, of expert insight and grounded intuition that provides an environment and framework for evaluating and incorporating new experiences and information. It originates and is applied in the mind of the knowers. This is something that is very, very important for us to realize. You also see here in this particular figure the relationship between knowledge, information, data and wisdom. We begin with data, and once we understand the relations, that is provide context, it becomes information. And if we see patterns in information based on our prior experience, prior knowledge, it becomes knowledge, and understanding principles can lead to wisdom. So, if we look at this from the point of view of increasing connectedness in one axis and increase understanding in another axis, this particular figure becomes quite evident. It's actually a representation given by Jean Bellinger. The branch of library and information science that deals with knowledge is knowledge organization. This term knowledge organization was brought into usage by the German classificationist Dahlberg. Ranganathan, though, preferred to use the term universe of subjects. Swellonius prefers not to use the term knowledge, but she suggests organization of information instead. However, in the last couple of decades, the term knowledge organization has come to be widely accepted, although all the three concepts, data, information, and knowledge, are abstract. We need to realize that data is at the lowest level of abstraction from which information and then knowledge are derived. You will find in this last slide a few websites, URLs of a few websites that are given, and I strongly recommend that you read these. I suppose I have given you a broad understanding of these three concepts of data, information, and knowledge. Thank you very much.